Hi, BStats. Just wanted to briefly explain the free response questions from the quiz last class, give you some explanation. So the first question was about a pharmaceutical company is giving a drug to some balding men and wants to see the effects of the drug. So they want to take a simple random sample of the 5,000 available men for the study or the experiment they're going to work on. So here's what you can do. You can do two things. And I was a little picky with how I was grading this. And so if you want to do it the old-fashioned way, you can take all 5,000 men, put their names on identical slips of paper. So each of them gets an identical slip of paper. You have to use the word identical. Put them into a hat or a jar, mix them, so you have to say mix, and then draw, in this case they wanted 20. Draw 20 slips of paper from the hat. Okay. The other way to do it would be to number all the men from 1 to 5,000. So make sure you choose from 1 to 5,000. So each person gets their individual number from 1 to 5,000. Use a random number generator and to generate 20 numbers, and you had to say ignoring repeats is also important for that one. So ignoring repeats. So if you missed like number them from 1 to 5,000, I probably marked you off for that. If you didn't say ignore repeats, marked you off for that. Describe in a short paragraph why you might wish to stratify a random sample. So here's the deal with this. If I were to pick from all of these people, it is possible that I could pick 20 men, and just by random chance, they all have dark hair. Or I could pick 20 men by random chance, they all are age 60s, in their 60s. Or I could pick, by random chance, they all are mostly bald. So what I can do is take my population and kind of separate it out into, like, say, light-haired people and dark-haired people. So now I'm stratifying the population. Alright, this is called stratified random. And then I'm going to pick 10 people from here using a simple random sample. I'm going to pick 10 people from here using a simple random sample. And so that guarantees that I've got light-haired people represented in my sample, and I've got dark-haired people represented in my sample. And I avoid the risk of having all light-haired people or all dark-haired people. And I could do the same with age. I could do like ages less than 50, and I could do ages greater than or equal to 50. And so that way I'm making sure that my sample, and do 10 from here and do 10 from here, making sure that the 20 people that I get are there's an equal number of less than 50, there's an equal number greater than 50. So whatever variable I want to make sure that my sample has, I can do that. Some of you were getting this mixed up, the sampling with experimenting and stuff like that. So we're just doing a sample. Number 19. This is an experiment, and the treatments are like how the experiment, what you're going to give to the people in the experiment. So like you could give a drug, and group A gets drug A, group B gets a placebo, and then you kind of see what's happening with that. So describe the treatments you will use in your experiment. In this scenario, the experiment was to either trade and grade or not trade and grade, basically. So each student is getting one of these treatments. You're either trading your paper and grading, and therefore getting back instant feedback, or you're not trading, the teacher's grading, and therefore not getting instant feedback. One possible confounding variable is time of day. So if you have a confounding variable, because it's possible, so you could pick block 1 or period 1. Let's not use the word block. You could pick period 1 and they would all trade, and then period 2 would all not trade, and then period 3 would like maybe all trade. Alright. The problem with that is a confounding variable might be time of day. People in the morning might not do as good, so that would possibly affect your results. So what you can do is you block, and the experiment would look like this. You've got all of your students, and then you separate them into blocks. Now, by chance, it would just be period 1, period 2, period 3, because there are 3 periods. And then within each period, you assign, some of them get traded, and some of them are not traded and graded. Some of these are traded, and some of these are not traded. Excuse my handwriting. I'm going fast. Traded and not traded. And then you continue the experiment. So then you look at the results of these, you look at the results of these, you look at the results of these, you bring it all together, you look at the results overall. And what this does, by assigning treatment to all the people in first block, time of day doesn't matter anymore, because these people all have the same time of day, and these people all have the same time of day, and some of them are getting traded, some of them are not getting traded grade, and then these people all have the same time of day. And so that's getting rid of, by blocking. This is called a block design for an experiment. You're blocking them. By doing that, you're eliminating time of day as a factor. And then the last question is, do you feel your experiment could be generalized to your statistics? And the correct answer would be no, because this was all done with a history class. You could generalize to other history classes, because that's what your sample came from, strictly history. If you wanted to generalize this to other classes, you'd have to pick your sample from more than just history classes. So we're going to say no for that, unless you gave me an outstanding answer for that as to why you would say yes. Some of these are open-ended depending on how you describe it, but more than likely it's no. So that was the quiz. And hopefully this helps.